Hello my friends, welcome again to my video channel. Today we will continue our work on the Kenwood TS130S. In the last video, in part 2, we have seen that there is obviously a problem in the AGZ and also in the ALC, as I assume the AGZ didn't work properly. It reacted in steps, weird behavior. The meter itself is okay electrically and mechanically, as we have seen by the test. Now we have to focus on the AGZ to get more information out of the transceiver. I will do some tests with different input levels, see what the AGZ does and whether the output power on the loudspeaker terminal is constant, whether the AGZ reacts properly and only we have a problem in the indication in the meter, or whether we have a problem in the AGZ itself and the meter shows the effect that we have a problem in the AGZ. There are two different components or units, so we have carefully to check it. That's easier, or that makes it easier to locate the fault. We have here a signal connected to the transceiver, 28.100 kilohertz, 50 microvolt. We have exactly S9 as it should be. The audio output from the loudspeaker terminal is connected via this dummy resistor to the input of the scope. It is, I think, 5.6 ohms or so. And we see when I tune over it, the frequency behaves as it should. When I reduce the RF gain manually, the signal reacts, the AGZ works, but when the gain is reduced too heavily, the S meter goes up and the signal goes down, as it should when I switch on the RF attenuator. Watch the S meter and watch the signal. It's in SSB mode, so it takes some time until this output reacts, but it is still the same when I switch off the attenuator. Nearly the same signal. I can reduce the signal from the generator by 10 dB, 20, 30 dB. It's nearly in the range of S1, but still we have full signal output in the loudspeaker connection, so I can say the AGZ for the receive path is okay. And now checking the transmit path, the ALC, automatic level control, mode CW. I can increase the carrier with this pot, with the setting. I go to send, transmit. With the output power, full scale is 200 watt. We have here 10 is 100 watt. I can increase the output power. We have here indicated the collector current. Creeping up a little bit. I think it's a meter. Contact is not good. When I go to ALC, nothing happens. 40 watt, 50 watt, 60 watt. And you see suddenly it reacts. Then I go down, output power 0. Crazy. This should go down because we have no output power. ALC should not work. When I go to receive and transmit again, it's okay. So I think there is still some sort of feedback loop or so in the circuit. Not okay. I have a dummy load with 50 ohms connected. Looks not good. I have to remove or take out the relay. I got some hints, suggestions to do this. Maybe the cleaning with the relay built in on the board, on the IF board, was not a good idea, was not good enough. So I will take it out and clean the outside and check the board whether there are other problems. I'm talking about this relay, which I cleaned on the board. Maybe not very successful. It's difficult to get between the contacts without damaging it. So it's better to take it out, to unsolder it. The board has to be taken out, not so easy, but on the other hand I see all connections, nearly all connections are plugged, so I hope I can flip it out in this way, loosen some screws in the corners. Should be done rather easily without bigger problems. The IF board is out. I can flip it out to unsolder the relay, and now I saw this. It's a white, what is it, a white powder or so, covering the board on the solder side. Looks strange, don't know what it is. Is it old resin, or was there water in it, or residues of a contact cleaner? Maybe someone tried to clean the relay with a contact cleaner. These are the residues on the bottom side. Could be. I'm not sure. Okay, I will clean it. Can be wiped away while it's only on the surface. And then I take out the relay. You may ask how to clean it. Well, I took a toothbrush, some cleaning gasoline. You can also use some EPA or other cleaning liquid, and then put some paper on it, and with a brush you can soak it up and clean it. When you see the residues. Well, I think that's it. I will try it a second time as I see. To take out the relay, it's the easiest way to use such a desoldering pump. And then pin by pin. The relay is out. Now we have much better access to the contacts, and I clean it with a strip of blotting paper and some contact cleaner, and I can remove the contact cleaner completely, so no residues are there, and the relay will work properly now. The last step is to check the contacts with a beeper. This is always the root, 4 times root, and this is the normal closed, normal closed, normal closed, normal closed. And here we have the normal open. I think I can do it without any cocoa clip. I touch the... Okay. So I can check all of the other contacts. Okay, they are good. The relay is reinstalled, the board is reinstalled, all plugs are connected. And now let's see whether we still have problems. Let's check the transmit path first to see whether it works. We have mode CW, carrier is set to 0. We are indicating here the collector current of the power transistor. Then I go to transmit and increase the output power, 20 watt, 40 watt. We have 10 amp, that's in line with the indication of my power supply. We have stable output of approximately 100 watt. When we switch over to ALC, we see that from a certain point of output power the ALC reacts and stabilizes the output power at 100 watt. That's okay. We go down to check it just to 7 megahertz. Same procedure. We have here the ALC again. And from a certain power of approximately 100 watts, the ALC starts to block the output to stabilize or reduce the output. Collector current is 10 amp, 15 amp. Yes, that's in line with the ammeter. So now it looks like that the ALC, the transmit path is okay. Let's go to 28. Same procedure. Again, we have the collector current. Oh, is this the switch? I think it's still the switch which makes the trouble. Let's switch to the ALC. We have no reaction of ALC. Approximately only 60 watt output. Collector current is approximately 13 amps. 130, 140 watt input. I think this is in line with the data sheet. And 10. There's the ALC reacts. Okay, seems that the transmit path is okay. The ALC is in the range how it should be. Maybe some realignment is necessary. Setting of the ALC threshold and the characteristic. But that's okay. And now let's check the receive path. And now we have the same problem again in RX mode. Input signal is 50 microvolt, should be S9 as we had in the last footage. Now we have only S3. That's the output in the loudspeaker connection. RF gain is fully maximum. When I reduce the RF gain, attenuator is switched off. When I switch on the attenuator, switched on, switch off, and all other knobs are checked. Narrow, bandwidth. And okay, I have to realign it, retune it. This has a little bit more attenuation, seems so. Mode CW. But in general, the sensitivity is bad. When I flip to transmit, carrier is set to 0. The relay is not the problem, I think. The problem is anywhere else in the RX path. Let's check it on another band. We are on 20 meter now, same problem. The S meter is a little bit more in the indication, but far away from S9. When I this is nearly S9. One moment. So that's S9. This is S9, and the input signal is 500 microvolt. Then we have S9. Not 50, it's 500. I need 20 dB more input signal. And then the RF attenuator is the same behavior as before. So we are losing 20 dB in the RX path. I don't know where, but it should be in the front end. Where the problem is, we check the voltages. Strange things are going on there. This is the part of the IF chain, the 3 filters which are fully equipped here. This is the IF amplifier stages, 3 dual gate MOSFETs. Here we have the output to the demodulator. It's a symmetrical signal. The demodulator is a ring demodulator, so it needs a symmetrical signal. That's all okay. I checked all voltages. These 3 FETs have the AGC line. This is the AGC line. I checked it with the RF gain, with the pot. It's all okay. Check the switching with the relay, whether this voltage is fed to this transistor. It's also okay. 2.7 volts source voltages, or 2.4 volt are okay. Drain voltages, power supply, everything is okay. I couldn't find here any reason, so my assumption was that the problem is maybe in the front end. And then I had the idea, well, let's check these two transformers, the alignment of the two transformers. And indeed, by realigning them to maximum, I suddenly had S9 for 50 microvolt input, 50 microvolt, as I had before. And I'll show you which transformers I'm talking about. We are talking about these three transformers, and especially these two needed some realignment. There was a huge difference. Okay, I took out this board and reinstalled it, but I'm very sure that I did not touch these two transformers, because it's not possible. They are protected by the metal hose on both transformers, and the slots here cannot be aligned just by touching them with a finger or so. And both were a little bit detuned. I don't understand. Do I have other problems, ground problems, or whatever? I will check it, but in general now I have full deflection S9 signal. When I switch it on, I can show it. Now we see we have here S9 for 50 microvolt. This is the output signal, and when I reduce the signal generator by 10, 20, 30 dB and so. One moment. It was 10 dB, 20 dB, 30 dB, 40 dB. Now we have a signal of 0.5 microvolt input. We still have a good output signal. And this is 0.15 microvolt. We still have a readable signal. Okay, the S meter, maybe the 0 point has to be adjusted, the bias setting, but I think it's okay now. I don't really understand what happened. Again, I will make a thorough check of the board. Maybe something is touching each other or so, or whether we have a bad solder connection, or some self-oscillation could also be a problem, that the stages have some self-oscillation which affects the sensitivity, and now it's gone, or vice versa. I do a check of all connectors which are plugged and unplugged during the cleaning of the relay. Maybe that there is a problem, but this even a plug here. Okay, there's one possibility, that the alignment of the two transformers depends upon the biasing of the two FETs which are connected to it. If there's a different bias, then we have different capacitive effects of the, or different loads of the transistors to the filter circuit, which could cause a realignment. But when I check all the by the way, I reduced the gain, so the output drops, so I'm beyond the AGC range. But when I move all the connectors, I can't see any effect. When I go to these two transformers where I realigned, nothing, so, and even squeezing onto the board or pulling it, shifting it, nothing happens. Nothing. I don't understand what happened. And now I found a solution. And it was all the time in front of my nose. Really, like this. What did I? I sat down in my leather chair in my living room, dimmed down the light, opened a bottle of wisdom and thought about it. And I found this. Cut. And now I saw this. It's a white, what is it, a white powder or so, covering the board on the solder side. Cut. What did I do? My first attempt to clean the relay was partially successful. It was successful in regard to the AGC to the receive path. Then I suddenly had S9. But it's important to know that the alignment of the cores of the filters was done in the factory, obviously with this white powder, and this white powder is conductive. And therefore it has an influence on the setting. When I first cleaned the relay, I did not clean the board. So the alignment was still okay, considering the influence of this white powder. Then, in the second step, I had the problem with the ALC in the transmit path still. I took out the board, cleaned the board on the bottom side and the relay, reassembled everything, and then suddenly was detuned. And this is clear now because I removed this white powder, and then the alignment of the cores was affected because the influence of this white powder was gone. So it's necessary to realign the cores of these filter transformers, and then it's okay. It took some time for me to understand this, but now it's clear. It's not a problem on the board, any contact or so. Now it is stable S9. It was only the fact that the alignment was done in the factory with this white powder, and when I removed it, when I cleaned it, then this influence is gone and the realignment is necessary. I had never seen such a fault, such a problem, but always it's the first time. I took out the switch again for the ALC and collector current switching. We've seen it is still not perfect. Took it out, and by the way, I've seen that the headphone connector, the jack, has no modification. First I thought there is a modification. I didn't see the wires, but they are behind the two resistors, and I checked it electrically. There is connection between this jack here, the rear side, and the internal speaker. This has priority. When we connect the headphone, all other speakers are interrupted. That's okay. But still we have a problem here with these small switches. I will again apply some contact cleaner. And as I've seen this switch, which makes a little bit trouble for IC current and ALC switching, uses only one set of these contacts. There's only one set used, so I will use the second one and make bridges. So we have a change over switch, single pole change over switch, two in parallel, so the contact is better. This can be done because one line is is not connected to the whole switch, only one set of contacts, so we can use the second one simply in parallel. And now we are at the end of part 3 of the videos about the Kenwood TS130S. There is still some work to be done. The alignment has to be checked. Maybe some components, some alignment points have to be repeated according to the manual, especially the transformers, the selective transformers, which had been affected by the pollution on the IF board, need realignment. The S meter has to be checked. The ALC, I think, should also be checked, the setting and other items, but in general I do not think that someone has tampered with this transceiver, because all slots, all ferrite cores are nearly pristine, no broken cores, no scratches, no signs of any abuse or so. So I'm quite optimistic now that all topics are cleaned and that this transceiver is ready. Stay tuned. Stay healthy. See you on this channel.